All right, welcome. This is the solution for week one for the distance learning packet. This is page 4 of week one of the distance learning. Here we have the movie price. This works as a performance task. Okay, so the inflation rate of an item measured how rapidly the price of the item changes over time. If an item price changes from P to Pn over a period of n years, right? There's supposed to be an n here. Let me just write that for you. Over the price of n years, then the annual inflation rate expressed by decimals is related to the following formula. This formula is the same thing as this, right? So if you want to get to a better understanding, let me just label this the formula that we're given based on this, because this behaves like an exponential growth formula. Okay? All right, because it is by an inflation rate. Okay? And let's see here. Let's make this green for you. This is going to be the referred to as the final amount right here. Exactly like our picture. The P0 is going to be your initial amount. The one's there, and it's going to be add because it's going to be a growth. The R, it stands for your rate of growth. Rate. I also you might also hear this as the common ratio. Okay, and the N is going to be referred to as the time. Okay, so you might I have either seen it like on the left, or you might have seen the core concept as to the right, but it behaves the same exact way. All right, so um, let's just grab this because this is what they want us to work with. Okay, all right, copy that. All right, so the average price is listed here. Okay, all right, using the formula. Boom, here's the formula. All right. Using the formula to find the price of a movie ticket in 2005, if the inflation rate from 2000 to 2005 was 3.53. Okay, so first of all, they gave us the R value. This is the rate, but we want the rate in decimal. So again, if you want to learn how to convert it to a percentage to a decimal, 3.53 divided by 100. That's how you get it into its decimal form. It's just to divide it by 100. Okay? So the rate here, the R, is equal to 0.0353. Okay, good. And what is the time? The time is from 2000 to 2005. So the time here is 5 years. Okay. So, we also need one more thing. We need the initial amount. So, I should have color coded this. Bad job. Okay, let me color code this so you could see this much better. Okay, so was the rate R equals to 0.0353. Purple was time equals to 5 years. All right. Okay. And then we need the blue initial amount. What is the initial amount? Well, the initial amount starts at your initial year, which is at 2000. What is its price at 2000? It was what? $5.39. So the initial amount was $5.39. All right, so we want to write our formula, but now we want to plug it in. All right, so let me rewrite the formula. Pn is equal to P0. 1 plus R is equal to the N. All right, so Pn is what you're trying to figure out. P0 is your initial amount, so that should be 5.39 parentheses 1 plus, what's the R? Again, the R has been decimal, so that is 0.0353, close the parentheses, and the time was in purple, and our time here was 5 years. Okay, all right. All you do, once you have it in the correct formula, plug it into the calculator, 5.39. No one could do this by hand, right? 0.03353, close the parentheses, to the power 5. There you go. Now you could round it. It's 6.411. So 6.41. Okay? Because again, this is a dollar amount. All right? I'm going to write this and I want to see if it makes sense. Can I write 6.411? No. This is a dollar amount, so make sure you understand where to round. And we only round to the nearest penny, which is $6.41. So you don't need this 0.1. Okay, so there you go. So the price, what does this represent? This, the $6, what's it? $6.41, right? Um, represents the price of a movie ticket at year 2005. That's what that price represents. Good? Okay. Next. If the average cost of a movie ticket in 1994 was $4.80, what is the inflation rate if you compare 1994 to 2004? Okay, you're looking for, here's the question mark. The question mark is the inflation rate. So that is the R, all right? So your initial year is 1994 and the value was 14.18. The final year is at year 2004 and the value is, what was that 2004? 6.21. So if you think about it, it went from here to here, right? It went from here to here. The inflation rate, you might have seen this as a type of sequence. This is growing up as a there is no common ratio. There is a common, sorry, there's no common difference. There is a common ratio here, right? This is geometric in behavior, okay? The formula for the common ratio is actually very simple, okay? The formula is the common ratio is your final value divided by your initial value. So our inflation rate R is just equal to $6.21 divided by 4.18, which is equal to, now let's just grab decimals. Okay. 6.21 divided by 4.18. Yep. So it grew at 1.48. Okay. So here it is the 1.4856. So roughly. Okay. So your R. Right. So what I can say here is that the inflation rate, right? If the price changes here, then the annual then the annual inflation rate is responsible by this. Yep. So you would say that the inflation rate is 1.486. Okay. This means that the, let me write this for you. Okay. The inflation rate is roughly 4.49. Okay. That means the movie ticket will price will grow will the price will grow over time because the rate is larger than 1. All right? Okay. There you go. If the inflation rate is smaller than 1, it would mean the price is decreasing it. Okay? Because again, think about it. If you are multiplying by a number that is greater than 1, the number becomes bigger. But if you multiply the number less than 1, it gets smaller. Okay? This is why the inflation rate here is 1.49. Okay? The okay. If you want to find the inflation rate between any 2 years, it would be ideal to use the given formula to solve for R, using your knowledge of exponents to solve the equation for R. Whoa, you want us to solve for R here? Ooh, okay, that's doable, but that's it's nasty though. Okay. Uh, I don't know why I don't know why anyone would do this, but okay. Solving for R this way? Okay. Alright, let's just rewrite the equation. Let's see what fancy algebra we can do here. Pn is equal to P naught. They call this P naught, right? The 0 is referred to as naught. 1 plus R equals to N. So I would get rid of the P naught first. So let's just write that in red. Divide everything by P naught. Divide everything by P naught. Yeah, I'm gonna need more room here. Let me just scoot this over. So what do I have here now? Pn over P naught is equal to 1 plus R to the power N. Okay, how do you get rid of the N? You are going to, let me just rewrite this. Copy, paste. Okay, here's the line. Now I'm going to get rid of the exponent by square rooting. That's an ugly square root. Up of square rooting. And this is to the power N. Here I'm going to also square root this to the power N. Okay, so what do I have left over? So I have an N. Pn over P naught is equal to 1 plus R. Okay, grab this because this is what it looks like after you simplify. Now I'm going to subtract the 1 to both sides. That's how I get the R alone. Subtract 1, subtract 1. Let me just, let's just move this a little bit further. Okay, what do I have left over? Well, I had the, originally I still have that P and this N root of Pn over P naught, subtract 1. Okay, this is the only thing left. Subtract 1 is equal to R. Okay, is that what they want? Use your knowledge to solve for the equation of R. Yep, this is R solved for, right? This is R solved for. Okay, that's pretty brutal, but there it is. Okay. Using your formula you came up with in part C to find the inflation rate between two non-sequential years of your choice. So I want to find the inflation rate between any two non-sequential years of your choice. Um, so let me just grab this and just pick. Okay, so let's grab 2013 and 2008. 8, 9, 10, 11, 12, 13. Yeah, that's 5 years. Okay, so I'm gonna grab these two. All right. Okay. Oh, N stands for your time. Please understand that N was our time, right? Yeah, N is our time. So N was our time, right? So N is equal to 8, 9, 10, 11, 12, 13. 8, 9, 10, 11, 12, 13, 5. 5 years. Okay? So from here to here, it was 5 years. Your initial. Okay, let me grab this formula. Your initial year, um, P naught is equal to 7.18. Your P final, your PN, that's the price at the next year, is 8.13. Okay, and yep, that's it. So how would it look like if we use the formula? So this is the formula, and let me just start deleting things and replacing them. The N becomes a 5. P naught, PN is 8.13. Your P naught is 7.18. Yeah, that can get me my R. So here's Desmos. That was the previous problem. Here's you go. All right, you hit this symbol, okay? Because it was 5 on top was 8.13 divided by 7.18. Good. Subtract 1. There you go. Oh, nope. Subtract 1. Okay. It's all right. It's the ones to the right. Okay. Notice how the radical stops here. So the answer is 0.025. 0.025. Okay. So the R here is R is equal to 0.025. All right. Okay. All right. Find the inflation rate between any two sequence years. All right. So there you go. Okay. There you go. If you have any questions, please let me know. But this is a performance task, and it's a little bit harder than normal. So that's why I decided to give you all the answers. Okay. But try it first. All right. There you go. Those are all your solutions.